Now let's talk about APIs. So, what is an API? Let's try to understand that with the example of the client, waiter, and the kitchen. So, imagine a client sitting in a restaurant, and then this client will do a request and it will order some food and it will make that request to the waiter. Then the waiter will go back to the kitchen and he will send that order. Then the chef will receive that order, and when the food is ready, he will call the waiter. Then the waiter will get the food and he will serve that food to the client. So in this scenario, we have the client, we have the waiter that it will be representing the web service API, and we have the chef which represents the server. So if we see it in another perspective, this will be the client. So the client will be a person running a web app on its computer or a smartphone or any device. And when the person press a button, for example, it will make a request. It will make a post request to the API. And this API will then request that data or information from the server. And when it gets the data, it will take it back to the client. So basically, an API is an interface between the client and the server. Okay, now let's talk about REST API. This is the most common API used nowadays. And how it works is like this. The client, which can be a web application, a mobile app, or any other software application, initiates the API request. It constructs the HTTP request with the necessary information, the request URL, and the request method. For example, get, post, put, or delete. Upon receiving the API request, the server performs the necessary actions based on the request method, handles any requested data, performs computations, accesses databases or external services, and generates a response. After processing the request, the server generates an appropriate HTTP response, which includes a status code indicating the outcome of the request. 200 for a successful response, or 404 for a not found response. Finally, the server sends the HTTP response back to the client over the network. The client receives the response, reads the response payload, and performs any necessary actions based on the response, such as displaying the data to the user or taking any further actions within the client application. So, for example, if you are using a website that after you click a button, if it will get a picture or an image, what is happening is that the API is going to send a request to the server with the, for example, a method post. And when the server receives this request, it will analyze that request and it will reply with a 200 for, for a successful response, or 404 saying that it couldn't find that information. Now, regard to API examples, we can say that APIs are used in most web apps nowadays, and you can find them, for example, when you are attempting to log in to a website that is requesting you to use your Google or Microsoft credentials. That website is using the Google or Microsoft API for login, or when you are attempting to buy something from Amazon or an e-commerce website and you are going to pay with, for example, PayPal or Visa or MasterCard, that site is using the API from PayPal, Visa, or MasterCard for receiving the payments or managing the payments. And also when you are trying to book a flight for an online travel agency and it shows you the map for where do you want to go. That map is using most probably the Google Maps API. So all these sites, all these web apps are not redoing that functionality again because it will take too much time. Instead of that, what they are doing is integrating all these different functionalities that already exist into their systems. Okay, now let's talk about the benefits of API testing. As we can see here in the automation pyramid, we can see that we have unit, API, and UI tests are the last ones. Why is that? It's because unit tests and API can be done in earlier stages of the development, but the UI tests can only be done when the development is basically finished. So it will be more expensive to fix a bug here than fixing a bug that is found here. So that's why these two are done first. So now let's proceed and talk about these benefits. So first, faster execution. API tests generally execute faster than UI tests since they bypass the user interface layer. This allows for quicker feedback on the functionality and performance of the APIs. Second, early testing. APIs are typically developed earlier in the software development lifecycle. By testing the APIs early, issues can be identified and resolved sooner, reducing the overall development time. Third, easier maintenance. API tests are generally more stable compared to UI tests since they are less affected by changes in the user interface. APIs tend to have well-defined contracts, making test maintenance easier as long as the contract remains stable. Fourth, broader coverage. With API tests, you can cover a wide range of scenarios by directly manipulating the API requests and responses. You can test different input combinations, error conditions, and edge cases without the need for UI interactions. And last one, integration testing. API tests are well suited for integration testing as they allow you to validate the communication and interaction between different software components. This ensures that the integrated system functions correctly as a whole. Now, that we saw this, what we're going to do now is that we are going to use a software called Postman and we are going to do some practical testing.